So in this question, we're told that the scores in a test are normally distributed with a mean of 40 and a standard deviation of 8. And we're trying to find the score exceeded in 5% of the tests. So the very first thing we do is just to write out our distribution, remembering that the standard deviation is 8, but we're writing down the variance. So it will be standard deviation squared, 8 squared. The questions asked us to find a value that is exceeded by 5%. So on a diagram, this is the position of the value that we're looking for. Straight away, I can deduce that I'm looking for an answer that's going to be greater than 40, and I can roughly approximate how far away from 40 it should be. I would suggest it will be a couple of standard deviations above 40. So we're looking for something around 55, 56. Okay, so with that in my head, let's actually process this calculation. 5% should be above that value. I'm going to write a mathematical statement for this. The probability that x is greater than or equal to a should equal 0.05. To put this into the calculator and make use of the inverse function on the calculator, we can say the probability that x is less than a is equal to 0.95. We need the less than probability to go into our calculators. We need to know the probability to the left of our unknown value to put into our calculator. So this unknown a value, I can find that by using the inverse normal distribution, putting in 0.95, that's the probability below, that's the probability to the left, and then standard deviation and the mean. Okay, when we process this, we get an answer of 53.1588. Okay, so that's what I was expecting, almost 2 standard deviations above the mean. So I'm happy with that, confident that I'm in the right vicinity. Without the calculator function, we could have found this using the standardization formula or the standardization techniques that we've also picked up. Let's have a quick look at how that would come out. So, starting from this statement again, the probability that x is less than or equal to a equals 0.95. If we standardize a, so we subtract the mean and we divide by the standard deviation, I can then say the probability that z is less than or equal to this statement equals 0.95. We can then find a z-score that matches 0.95 below, or more interestingly, 5% above. There is a z-score from our alternate tables, from our percentage point tables, that has 5% above it. And that z-score is 1.6449. So this fraction, a minus 40 over 8, equals 1.6449. Okay, and just some smart rearranging from here gets us a value of a which is 53.1592. So, not the exact same answer, and our calculator answer is the more accurate of the two. The z-score used on the right hand side, the z-score used is only correct to 4 decimal places. Our calculator would have used a z-score that was correct to an infinite amount of places, or an arbitrarily long number of decimal places. So both of these are actually the same answer to 2 decimal places, so we'll be happy with anything that rounds to 53.16.